today we're going to be using Mathematica again, but today we're going to focus on there's an entirely new layer on how to share finished projects and essentially how to make your Mathematica projects more portable. I'm sure you talk to people, I talk to people where you make something really, really neat in Mathematica on your laptop, and then you think to yourself, great, I want to show this to people. Within the bounds of your university, you have a site license, and so it's straightforward for people to get Mathematica and take a look at what you're doing. But anytime then you cross out of the campus, or if you just want to put something on the web and have it be a little tool on the web, that's what this new technology is really good for. So I think in the announcement for today, we asked you to go and start a trial license just so that we could make sure that you have this new, just the resources to type along with me and do this stuff. If you haven't done that, type along anyway. And I think after the session, if you contact us, we can get you the licensing where you can run this yourself and start to experiment with it. But you should be able to type along with me. You'll be able to get to a certain point. There are what we call basically testing, enough resources for testing included with everybody. First thing though that I wanted to mention, people ask us, why should I put the time to work in Mathematica or learn it, or what's Wolfram doing these days? We get these questions all the time. We were just talking before we started today about there was an announcement just this week about ChatGPT, where there's a lot of buzz around ChatGPT. Some of it is pedagogical, some of it is philosophical, some of it is just sort of marveling at what it can do as a chatbot. But as of just a couple days ago, they released their first set of plugins. And among these first 10 plugins, one of them is Wolfram. So there's Wolfram, there's OpenTable, there's Instacart, these other things that are just not our world at all, Expedia, et cetera, et cetera. We're the math and science one. So before I start, I think we pop up in all sorts of really useful contexts. So learning Wolfram is very, very helpful to support math courses and to understand concepts of what you're doing on campus. But it's also a really good language and it's a really good skill. A lot of people describe it as kind of their secret weapon when they get into companies where they try ideas, they prototype an idea, whether that's pure research or data science or physics or engineering. There's a lot of use of Mathematica in industry and government labs and things. In particular in this, the next session, which is in a couple of weeks, we're going to talk about machine learning. I'll try to sprinkle in some examples with this as well. The idea, though, is there have been all sorts of blogs and discussions about ChatGPT and how it works. And Stephen Wolfram describes its behavior sometimes as hallucinations. I mean, it is using a big neural net. It is basically scraping the web and a bunch of publications. And when you ask it a question, it's just using percentages and kind of this big corpus of billions of sentences of text to piece together an answer. It's not really too clear on precisely what it's saying. It's sort of like playing the odds one word at a time, I think. And that can be very interesting and that can be very detrimental. Often though, it doesn't know what it doesn't know is how I like to describe it. So when it hallucinates, it has no idea if you ask it something even just sort of simple numeric arithmetic or something like that, and it gives you an answer, it seems as if it's very sure of the answer. But whether it is or not is a different story. So our plugin is a way to wrap us in this environment where you can use its ChatGPT's very, very useful way of phrasing things as a conversation, but then you can fly its answers through Wolfram Alpha, where we are very good at curating data and we know what we know and we know what we don't know. So when those two things are mixed, our accuracy, our data, our curation our natural language processing, which we were using last time, mixed with their conversational way of phrasing things. It's a pretty interesting combination. So this is 24 hours old, so I don't people are just tinkering with it a little bit, but we'll see if next time uh maybe we can play with this a little bit. Although I don't know how in depth we can quite get, I think. Okay, so before I start here, is there anyone who has not signed up for Mathematica Online for this session through a trial license and just needs to know where to go for that?
I haven't signed up.
Okay. So if you go to Mathematica trial, so it's wolfram.com/mathematica/trial, and I'll put this in the chat here as well. Chat pod. Everything is coming out of my mouth. Okay, so in the chat pod, you do need a what we call a Wolfram ID, which is a login into our system. So it'll either ask you to sign in, which it would be your Wolfram ID would be your wku.edu email. If you've downloaded or used Mathematica, you should already have an account, or you can create one. But I'll get started here, and I think you'll be able to kind of catch up as well. But this will be the spot to get that.
Okay, thank you.
Okay.
If we have Mathematica on our machine, do we still need to do that?
Yes and no. So if you've got Mathematica and you're logged in, you get a certain number of resources in our cloud for testing things. I have not tested how far we're going to go, but I think you're going to hit the limits of what we include without a trial license. So you'll be able to type along, but a couple of the examples that I do, you might get a few error messages. But if that happens, then you can just go and get the trial after the session, basically. Okay, so today, myself and Abby are going to talk. I'm going to do most of the talking today, but so I'm a Wolfram certified instructor. Abby helps the campus with the site license. So if you've got questions, and I'll try to save time at the end for questions, but if you have questions about, I'd like Mathematica on my second personal laptop, or does it work on Windows or Mac, or does it work on my Linux machine? Abby's the person for that. The answer to all those questions I just asked is yes, by the way. So the agenda for today, we're going to delve into more involved computations. The last session was the basics, where we primarily did one command at a time, or maybe just a couple commands. This time we're going to do more involved computations, multi-step computations. We're going to do a few programming basics. If you're not a programmer by trade, don't worry about it. We're not going to delve into a lot of computer science jargon, but we are going to do some simple loops and some repetitive computations where a few programming basics are good. We're going to do that through, so we're going to learn these things through two examples mainly. So the first is a Scrabble solver. So the idea of you've got Scrabble letters, can you use Wolfram language to tell you what the best word is that you can make with those letters? Second is web scraping and geomapping. All of these things that I'm going to show you, they are very good general skills for things like mathematical modeling or numerical methods, or all the things where it's math oriented, but you want to do an involved computation. These building blocks are really good for those things. I'm starting out though with Scrabble solver and map, just because those, conceptually, those are very, very easy to understand. So I'm starting with building blocks that are that I don't have to, have a detour to explain the math and the programming. We're going to stick to simple concepts. Okay, so if possible, I would like you all to type along with me. And I'll try to go at a pace where you can do that again, just like last week. We're going to be typing a lot of things that are maybe multi-line and things. So we're going to copy and paste expressions and things like that. But if I start going too quickly, just let me know and I'll slow down a bit, or I'll let you catch up. But my goal at the end of this is you will have a notebook where you do all these calculations, and then it'll be a really good basis where you can use these things that you've learned for other projects as well. Okay. Let's start then. So in your Mathematica, you probably have a blank screen. I went over how to make these sections or subsection cells or text cells last time. So I'm not going to cover that again. We're just going to be typing computations this time. But just as a refresher, wherever the horizontal bar is, if you just start typing, then the expectation is you are typing in Wolfram language, the proper language in Mathematica, and what you're typing in is meant to be a calculation, what we call an input cell. So the first thing we're going to do is start with the Scrabble solver. So let's start with the function. So let's experiment with some strings and some lists first, and then we're going to work our way up to something that gives us words based on just any letters that we've got in our hypothetical Scrabble hand. So the first function I want to look at is called characters. So type in capital C, and Wolfram language commands are always capitalized, always spelled out, and they use the square brackets. So it's characters, open square bracket, and then characters uses a string of text. And so strings are surrounded by quotation marks. So type a quotation mark, and then let's type in the word Wolfram. If you're in a recent version of Mathematica, the close quote and the close brackets are there for you, but you can always just type close quote, close bracket if needed, hold down Shift and hit Enter. So throughout the thousands and thousands and thousands of functions in the language, there are all these really useful functions to do pattern matching or to work with, to filter lists or to extract parts of lists. In that vein, there are a bunch of functions to work with strings of text. Characters simply takes a string of text and it makes a list. So now we have a list where each element is the letter of that word, basically. Let's do the opposite. So let's type in string join function, capital S, capital J. So string join, open square bracket. And then we're going to put in a list of letters here. So quote, T, close quote, and then comma, and then quote H, close quote, comma, I, close quote, S, close quote, and hold down and Shift Enter. So string join takes a bunch of individual strings. Those could be letters, those could be a word, those could be things that we join into a sentence, but it is essentially making one string out of this. This is important because our Scrabble solver is going to start with individual letters. We're going to combine them and we're going to fire them through Mathematica's dictionary to see which of them are words. And we're going to take a somewhat brute force approach to this. So we're actually going to start to do things like permutations. So let's copy and paste characters here. So you can highlight this whole thing, or if you mouse over the function and you triple click on it, it will highlight just that expression. And you can either go to the edit drop-down menu and choose copy, or you can use the typical on Windows, it is Control-C, I think. Yeah, and on Mac, it's Control-C. So copy that and paste it down here. And we're going to wrap another function around it. So click before characters, and we're going to type in the function permutations. If I can spell it. And then open square bracket. You'll notice this one has a little red bracket because there's no matching close bracket. Click to the end of this and type comma. And we're gonna force the permutations to have at least 2 letters here. So open curly bracket and then type in 2, comma 7, close curly bracket, close square bracket, and hold down Shift and hit Enter. And let me pause there for a second. So we've done 3 calculations, but is anyone stuck getting Mathematica launched and running and typing along? Should I pause for a bit?
Anyone in the audience? Everybody's fine. I think we're good.
I just want to mention, by the way, I was a little late today, but if anybody needs any help, I'm here. So,
Okay,
yeah.
good. Thank you, Jacob. Okay, good. All right, so this output is a big, long output. So essentially we're saying, take these letters and give us every combination of the letters, any 2 letters, any 3 letters, any 4 letters, up to 7. And so these aren't words, these are just all permutations. So you can see that it gives us the first couple. It says, okay, I am suppressing 13,679 elements in the list, and then I'm going to give you the last couple. So by default, if you print something really huge to the screen, Mathematica wisely tells you, you probably don't want to print 13,000 things to the screen. And so I'm just going to shorten that for you. Next thing, let's start to experiment with the Wolfram dictionary. So the function for that is called dictionary lookup, capital D, capital L. So let's type in dictionary and then capital L, lookup, open square bracket. And then we want something like, well, let's do Wolfram. So dictionary lookup Wolfram. What we get here is not all that exciting. Really what we're getting here is, yes, I can confirm that there is a word in the dictionary called Wolfram. We could get a definition, we could get synonyms, we could get quantity of syllables, we could get a lot of things. In general, though, we just want to confirm it's a word. Let's click here in this same input and just hit Enter instead of Shift Enter to get a second line. And let's do a second. So copy this and let's just do a second calculation. And instead of Wolfram, let's just type in some gibberish here. Doesn't matter how long it is. So now we're doing 2 calculations, and essentially what dictionary lookup is saying is, yes, Wolfram is in the dictionary. No, Azwurvv, or whatever, however one might pronounce that, is not in the dictionary. So you might imagine here between this and this, we've got the building blocks here where for a Scrabble solver, you can start with letters, you can combine it into a word, or we could just get the permutations of those letters, all of them, combine all of them into a word, look them all up in the dictionary and see which ones come out as a word and which ones come out as empty. And so that's what we're going to do. To do that, that's a very repetitive command. So basically what we want to do is take each one of these little things and do exactly the same operation on each of these. So we want to take this and make this into 1 string and fire it through the dictionary. We want to take this, make it 1 string, fire it through the dictionary. So that's a perfect looping thing for a programming language. My favorite looping function in Wolfram language in Mathematica is the table function. There are many looping functions. Those of you that have a background in programming, there are for loops, there are do loops, there are while loops. Those of you who have a functional programming background, there are functions like map a function over a list. There are functions like nest or nest list, where you're nesting, where you're running a function over the last output a bunch of times. Today, we're going to stick to table because I like table. So let's type in table with a capital T, open square bracket, and let's do a simple one first and work our way up here. So let's just do string length, capital S, capital L, of, and of is open square bracket again. And so table, it has a temporary local variable where you can assign a different value to it, and then it's going to run this main body of the calculation on those on those values sequentially. So let's make our local variable word, and then right arrow, and then hit comma, and then open curly bracket, and then let's type word again. So that's going to be our local variable, comma, open curly bracket again. So we actually want to give it a list of choices here. So let's do quote, I don't know, let's do Kelvin, close quote, comma, quote, Western, close quote, comma, open quote, Kentucky, close quote, comma, open quote, university, close quote, and the rest of it should be there for you. So now you can see we've sort of finished our thought. So we're going to run this command, string length of word, word being Kelvin first, Western second, Kentucky third, university fourth. So what we're going to get here is 4 numbers back, the quantity of letters in each of those words. So 6, 7, 8, 10. That's kind of funny, actually, that it's an interesting sequence. Anyway, but that's what table does. It gives us a list of outputs, which is pretty good. So now let's take the next step where, why don't you copy and paste table? So just highlight the whole thing, hit Command C. Sorry, no. Sorry, I'm on a Mac and I'm using a Windows keyboard, and so this key always confuses me. It's say again, what is it, Jacob?
Command C.
Command.
So-
Okay. So I was right the first time. Okay. All right. So just copy and paste. I shouldn't spend this much time explaining copy paste. I think you're all familiar with the concept. Let's replace string length first. So what we're going to want to do here is grab dictionary lookup. So copy that. Highlight the string length of word here, or you can triple click on string length of word, and then it highlights just that, and hit paste. And we need the string join part as well. So go up, copy the string join, and paste that. And we're actually going to replace this bit here. So now it's dictionary lookup, open square bracket, string join, open square bracket, and then a couple close brackets. You'll know if you did this correctly because the brackets will be black. If you see any of them that are highlighted red or purple, that means you lost a bracket along the way. You can also do extra carriage returns when you're creating examples like this. So click before the D and don't hit Shift Enter, just hit Enter. And then go right before this curly bracket and hit Enter. And go right before this curly bracket and hit Enter. And then between the curly brackets and right before the final closed square bracket. So you can see now that we've got this main body of the table. This is the variable where we're going to swap in values. And these are the things that we're swapping in. But it's easier to see the brackets this way. Okay, we want to do this on Word and not the specific thing. So take this out and just type in word in there. So string join of word and then dictionary lookup. And then instead of this, we're going to grab that permutations thing. So highlight the permutations input, copy, replace this specific list. So you'll want word, comma, and then paste. And then hold down Shift and hit Enter, and let's see where we're at here. Yeah, good. So it's effectively what we've done here is we've started with our Scrabble hand of Wolfram. We've split it into characters, so a list of characters. We've taken those characters and done permutations of all the, 2 through all of the letters. We put each of those through dictionary lookup one at a time, one at a time, one at a time. So for each of the 13,000 permutations, we get not in dictionary, not in dictionary, not in dictionary, of is in the dictionary, or is in the dictionary, and so on and so on and so on and so on. So a bunch of empty data there. So at the beginning of the table, click your mouse and let's type in delete cases, capital D, capital C, open square bracket, and then click to the end and type comma, and then just open close square bracket, so an empty list, and then close square bracket. So now we're going to run this, everything in the table. We get the result, we feed that into delete cases to delete the empty ones, and now rerun it. So now this is much more reasonable. So Wolfram is a word, formal is a word, moral is a word, molar, flora, et cetera, et cetera, et cetera. And it's even sorted for us, which is pretty nice. We could use a function like sort or sort by to do that if we wanted to. But now we've got a pretty reasonable Scrabble solver. Let me pause there for a second. Does anybody need a moment to catch up?
Yeah. Just a few seconds, yeah.
Okay.
Are we all good? People are still typing.
Okay. While people are typing, I'll kind of set up the next thing we're going to do. So the next thing that we're going to do, I mean, this now is, we're in our notebook. We've created this computation. It's a self-contained thing. What we're going to do is define our own Wolfram language function that does this. So in Mathematica, the syntax for that is the same. So if you define a mathematical relationship, like f of x is x squared plus 5x plus 2, it is the same syntax to do that versus to create just a general program where instead of giving it an input like the f of x I just described, it sort of expects some sort of number. You're doing something mathematical. In this case, we're expecting a word, but the pattern matching layer in Mathematica and Wolfram language is extremely useful. It goes a long way. And that same pattern matching layer is used for all of this sort of stuff. So, which is nice. So once you learn that for something like calculus, you can actually very easily apply that to some sort of program like what we're doing now. So let's start that. Let's first I'm going to teach you the basics. So I'm going to teach you how to do the f of x. Let's type in f, open square bracket, and then x, and then underscore, close square bracket. And I'll talk through this in a second. And then instead of equals, let's type in colon equals, and then x plus 5. And then hold down Shift and hit Enter. So this x underscore is actually a pattern. This is the basics of pattern matching in Wolfram language. So what we're essentially saying is whenever we use the symbol f, whatever is in here, whatever matches that pattern, replace that with x equals 5. The colon equals is a delayed assignment. So whatever is over here, it's going to run only when we access this function. So, and that has pros and cons, but most of the time for a function, that's exactly what we want it to do. So if we type in something like f, open square bracket, 5, close square bracket, and hit Shift Enter, then what we get is 10. So 5 is the thing that matches the pattern, and then it's 5 plus 5, and then it's 10. Pretty straightforward. But that pattern can be anything. There's a way to restrict this. So if we wanted to have the function only work for integers and have it not work for anything else, we could do that. But for today, we could do something like f, open square bracket, and then we could type open curly bracket. So we could actually type in a list here directly, and we could put in 2, 3, 2, 3, 4, 5, 6, something like that. Close curly bracket, close square bracket, hold down Shift, hit Enter. And now what we've done is put a list, and for each element of the list, it runs that function, and it just adds 5 to each of them. So these patterns are very flexible. As it stands now, we could put a string through there, or we could put an image through there. The result would just be image plus 5, so it wouldn't be very exciting, but it would return an output. It would just say, I don't know how to simplify the expression image plus 5. That's the simplest, most exact form that Mathematica knows for that particular expression. But all of this, the generality of the pattern matching extends to everything. So let's take what we did above and let's wrap it up in a function. So let's type in Scrabble solver, and typically when we make our own built-in functions, we use lowercase just to make sure that we don't inadvertently conflict with one of the built-in functions. Like if I try to define my own function called mean with a capital M, there's a built-in function called mean, and so Mathematica will give me an error message, which it should. It'll essentially say you can't override one of the built-in functions. So let's do Scrabble solver. So lowercase s and then uppercase s, open square bracket. Let's, in the pattern, we can call the pattern anything we like. So let's do something more descriptive. Let's have the pattern be called letters. So letters underscore, and then right arrow, and do colon equals. And then what we're going to do is just copy and paste everything up here. So highlight the whole thing, copy it, come down here, paste it, and then we'll make one change. So instead of Wolfram here, type in letters. And you don't need the quotes. So when we access the function, we'll use quotes. So now essentially what we've done is this exact same thing is going to run, but it's going to run on the pattern letters, whatever letters is. So hold down Shift and Enter. This blue turns to black, so Scrabble solver is now a built-in function. We can say question mark Scrabble solver and hold down Shift and hit Enter, and we get the definition, just like how we get the definition of question mark mean. Mean gives the statistical mean of the elements in the list. You can make your own kind of fancy thing that prints out here for your own function. By default here and in general, it just gives you the pure definition. But now that we're armed with this, we can run this now on a bunch of different things. So I mentioned before that these building blocks are really useful. So what we've done is something very repetitive here. We've done a table where we're generating a whole big list of things and then testing it and filtering things out. We're looking for a pattern. A lot of times mathematically, people might look for patterns where you search a big space of fractals, or you search a big space of integrals, or you search a big space of, I don't know, something. But really, essentially what you're looking for is something that satisfies a pattern. And so this sort of setup would work equally well for something very mathematical as well. But let's use this and actually, so this is repetitive, but let's use this and do something repetitive with that. So let's set up, instead of running one set of letters through it at a time, let's run a bunch of letters through it. So there's a function called character range. So capital C character, capital R range, and open square bracket, and then do quote A, close quote, comma, quote Z, close quote, and hold down Shift and hit Enter. Character range is a lot like the regular range function in Wolfram language. So if we say just range with a capital R, open square bracket, and then 100, that gives us the first 100 integers, which can be really useful. Character range gives us the A through Z all characters, basically. Let's do one more thing with character range. So click before character range and type in random choice, capital R, capital C. So random choice, open square bracket, and then click to the end and type comma, and then 7. Scrabble hands are always 7 words. Close square bracket, hold down Shift and hit Enter. So now what we've got is just a random choice of 7 letters out of this list of all letters. And if you click up here and run this a bunch of times, it's different each time. Stephen Wolfram likes to say that the randomness of Wolfram language is very good randomness. I mean, they are pseudo-random numbers, but this sort of intersects with his interest in cellular automata and stuff like that, where some of those things are hiding in the background here in our random number generators to give really I don't know if this makes mathematical sense. Really random numbers, really random pseudo-random numbers. I don't know. That's probably not a very exact way to put that. But for our purposes, we're getting several random Scrabble choices here. So let's make a list of lists here. So click at the bottom. We're going to make a new variable. Let's call it so lowercase m. Let's say mult puzzles. So like multiple puzzles, but you can call it whatever you like, equals. And what we want to do is make a list of a bunch of these. So this is generating one at a time, but let's generate a bunch of them. So let's do a table, capital T, open square bracket, and then let's just copy all of this and click into the table and do paste. Table has a syntax where we can just run something 10 times. So do comma 10 and hold down Shift and hit Enter. So there is no local variable here. There's nothing that is like a min or a max where it steps through values as we generate the table. And there's nothing here where it's swapping specific values. It's just literally running this 10 times. And so if you run it again, it's a different list of 10 and a different list of 10 and a different list of 10. These curly brackets is the list of lists, essentially. But now we have mult puzzles. So now what we can do is we can make another table. So we can say table, open square bracket, and then Scrabble solver, where this is a built-in function now, and so it pops up in the command completion, which is pretty handy. Open square bracket. In this case, we can do P, like P for puzzles. Close square bracket, comma, open curly bracket, and then P, comma, mult puzzles. And then the close curly bracket and the close square bracket should be there. And hold down Shift and hit Enter. And then we're going to get something huge. Well, actually, it's not that huge. So for each of these, you can see now we've got a list of a list of a list. So for the very first one here, and your results are going to be different because your random is going to be different. But my first one, these are all the solutions. My second one, these are all the solutions, and so on and so on and so on. Let's do one refinement here. So click before Scrabble solver and type in last with a capital L and open square bracket and put the close square bracket behind the close square bracket of Scrabble solver. So now each time through the loop, it's Scrabble solver of P and then last of that, and rerun that again. Last just takes the last element in the list. In this case, it's pre-sorted. And so we get the solution with the largest number of letters, the longest word essentially. I actually have a case here where there are no solutions. So it's taking last of the empty list, and it's saying that particular thing has 0 length. There is no last element of this where there is no solution, which is kind of interesting. Okay, sorry, if you haven't saved here, you might want to do that. You can go to File and Save As. And then you've got this for later. Okay, any questions at this point? Okay. All right, so now let's, and this is going to be the part where if you don't have Mathematica Online, you should be fine up to this point, but we're going to do one thing here where if you don't have Mathematica Online and you get an error message, don't worry about it. Just later after the seminar, email Abby or myself or sign up for a trial, email us and we'll extend the trial. And then when you rerun the same code, it will work. And if you want a copy of the things that I'm typing later, let me know that as well. But we're going to use a function called cloud deploy and a function called form page. So let's start with form page. So let's type in capital FORM, capital P for form page, open square bracket, and form page does what it says. It's going to create a form for us, which we're then going to post on the web. Form page, the first argument is so the people who go to our website, what should we prompt them to type in? So we're going to prompt them for a string, and we're going to call that letters. So type in quote, letters, close quote, and then type in dash, and then greater than to make an arrow. So the hyphen, and then greater than, and then quote, and then string with a capital S. So there's going to be one input in this web app, and that one input is going to be a string, close quotes, and then comma. And then we're just going to grab the thing we were doing before. So the delete cases, we don't need the Scrabble solver, although, yeah, actually, let's try. I think this is actually going to work. Let's try that actually. Grab Scrabble solver of P and copy that and paste that in here. And then replace P with the pound sign and then letters. And then right arrow to get on the other side of the open square bracket and put in the ampersand symbol. So you've got Scrabble solver, open square bracket, pound sign, letters. This letter's matching this letters. Close square bracket, the function sign, and then close square bracket. And then hold down Shift and hit Enter. And what we've got here is an actual form. So now if I use this and I type in Wolfram and I click Submit, I've got my own little GUI here where it gives me these solutions. But now this is a fully, it draws an input field here. It gives me a submit button, and it's a full sort of mouse, kind of a mouse-driven GUI interface here, which is cool. Copy this whole thing. We're going to do one more step here. So highlight it, copy it, and then let's type in the function cloud deploy, capital C, capital D. Open square bracket, and then paste and then hold down Shift and hit Enter. So now what we get, actually, let's make one tweak here. Click right before this ending open square bracket and hit comma and type in permissions with a capital P, and then arrow, which is dash greater than, and then just choose public, the second one in the list. So quote, public, end quote, and then hold down Shift and hit Enter. And so now what we get is a URL. Now let's see how, let's see if this works. So now I'm sharing my web browser. So this is my Firefox on my machine. It's wolframcloud.com/objects. And each of these web apps has its own encoded address. So I can put this in the chat, I can give it to all of you, and you can run this. But if I run this on Kelvin and I hit submit, yeah, gosh, okay, that's great. So so the definition for our user-defined function solver was local to our machine. But when we ran cloud deploy, Mathematica is smart enough to say, you're using that function. So I'm actually going to grab all the definitions out of your notebook and put it in Wolfram Cloud so that when a completely different person runs this and they run this code, when I click submit, the code is Scrabble solver. And Mathematica doesn't know what Scrabble solver is because we just invented it, but it actually grabs the definitions and it runs and it works just fine. So now I get Kelvin, Liven, Lichen, et cetera, et cetera, et cetera. So this is now a fully independent to my machine thing. So you can send this to your friends. They can run it on their phones. They can run it on an iPad. When they click submit, the calculations run on our servers. The author has a certain pool of time on our servers, and it just deducts from that pool of time. In general, if you have Mathematica Online, that pool is very, very large. If you've got just regular Mathematica, the pool is not so large. You can probably do one or two of these things, but not a whole lot more. But that's essentially what's happening. It's now making our example super portable. People don't have to understand Mathematica or Mathematica syntax to run it. It's now the fully live share with the world version of this thing, which is pretty cool. Okay. Yeah, go ahead.
Can you use this for like survey purposes? Like you collect some data and then store it somewhere, and then later on you just check what is collected?
You absolutely can, and we absolutely do. So there's another collection of functions called data bins. Oh wait, actually, so like data bin add would be a good function. So data bins are, we first built this for Internet of Things. So we thought people would have Raspberry Pis and sensors and all sorts of things, and they would want to aggregate data, and they do use it for that. But as it turns out, it's much more useful for a lot of different things. You can create a data bin on our cloud, and you could make a web form. And when I click submit, everybody who takes the survey, it adds their results into that data bin. And then you as the author of that can say, okay, it's been a week, what's in my data bin? And then you get all of the responses, and then you can do some analysis on that. But yeah, it's very straightforward to do.
Thank you.
Sure.
Do you need special permission to create a data bin, or can anybody just do that?
You do need to have Mathematica Online to create a data bin as well.
Okay, thank you.
Really anything that is storing or running computations on our cloud uses Mathematica Online. Okay, where are we at in terms of time? Okay, I talked about ChatGPT a little bit longer than I intended, but let's do a simple version of the second thing that I have in mind, which is text scraping. So, okay, so let's see. Let's start by doing something simple. Let's use the function import. So what we're going to do is import all the text of a website and save it with a symbol name. Let's make that symbol name web data.
You make your account on Wolfram.
So I'm using lowercase w because it's my own function, and say equals. And then let's use the import function. We used this in the last session as well. You can import a spreadsheet, you can import images, you can import all sorts of stuff. Actually, I think we were importing a website last time as well. So import, open square bracket, and then I'm going to put a URL in the chat for those of you who can just kind of grab it. But I'm going to put a URL for Wikipedia on there. The rest of you can type it. So type in quote https colon / en.wikipedia.org / wiki 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 / zoom, the capital Z, underscore video with a capital V, underscore communications with a capital C, close quote. And then, yeah, let's just do this. So hold down Shift and hit Enter. So it's gonna give us a big long output. But effectively, what this is all of the text for the Zoom Wikipedia page. So let's go back and click at the end of this and put in a semicolon, and then hold down Shift and hit Enter again. So we're importing it. We're storing this big block of text as web data, but we're suppressing the output. Now let's do a couple things where let's find all of the cities in this. So type in the function text cases, capital T, capital C, open square bracket, and then web data. So text cases of web data, that big super long string, comma, and then quote, capital C, city, close quote. And then we want to do an arrow, so dash greater than, quote, and then capital I, interpretation, close quote, close square bracket, and hold down Shift and hit Enter. This is going to take a while, so I'm going to talk you through this while it goes. So text cases is one of these functions that the ChatGPT technology finds so interesting. This is our curated data. So we have data on cities, we have data on zip codes, we have data on planets, we have data on stocks. Effectively, what we're doing here is we're saying, go through all of this, scan through all the words, find all of them that correspond to some city within the world, Hong Kong, New York City, San Jose. And then this interpretation just means if there's any ambiguity, choose something that is a city, basically. So this just helps us for later. And so what we get here is this entity notation. So when you mouse over this, there's a function called entity in the language, which says, we know what San Jose is. And now that we've identified San Jose as an entity, we can get all this data. Like we could get population of all these cities, we could get elevation of all these cities. We could also get a map of all these cities, which is what we're going to do. So now let's do, actually, let's run this again, where let's give this so click before text cases and let's give this a name. So let's just say cities equals, and then rerun this thing. So we're just going to store the results as this symbol cities. And then let's type in the function geographics, capital G, capital G. So geo graphics, open square bracket, and open curly bracket. We're going to give this a little bit of styling. So type in red with a capital R, comma, point size, capital P, capital S. So point size, open square bracket, and then medium, close square bracket, and then comma, point, open square bracket, and then cities, and then the close square bracket, close curly bracket, close square bracket should be there already. And then hold down Shift and hit Enter. And now what we should have, okay, so it doesn't like, it doesn't like, I think it doesn't like that we've got city in here. Okay, so let's do, okay, let's add in here. So for cities equals, before text cases, let's type in cases, open square bracket, and then at the very end here, type comma, underscore, entity with a capital E, close square bracket, and then hold down Shift and hit Enter again. Basically what we're doing is getting this results, and then we're saying, give me all cases that are an entity. And so you'll notice now that one that was just a text, kind of that misidentification is gone. And then we should be able to run this. Yeah, there we go. And now we get points for all these cities. So in the blink of an eye here, we've gone from an external web page, a huge block of text. We've extracted just cities, and we've made a map of all the cities. So these are all the cities on the Zoom web page, where if you're curious about a company, or if you're curious about a scientist or a famous mathematician, you could get a quick look at where did they go to school, maybe where did they live, did they talk to other people in other countries, et cetera, et cetera. So this is kind of a cool thing. Let's wrap up here. We're running right at time, but let's wrap up where we make another web app, but we're going to make a web app that does this essentially. So let's do cloud deploy, capital C, capital D, open square bracket. And then let's do form page, capital F, capital P, just like before, open square bracket. So in this case, what we want people to put in our web app is the name of a Wikipedia page, basically. So let's type in quote, and then URL, close quote, and then dash greater than to make an arrow, and then quote, string with a capital S, close quote, and then comma, and then parentheses. So we're going to do a couple things here. Now within the parentheses, let's first grab, yeah, we're going to grab a bunch of things. First, grab the web data equals. So highlight that whole thing and copy it. And click between these parentheses and click paste. And then we're going to replace this specific URL, so the quotes and everything, and do $, the pound, and then URL. So now when people use this web form, we're going to import that. Next thing, go up and let's copy all these cities. So highlight that whole thing, copy it, go down. And we can start to do extra carriage returns here as well. So after this semicolon, you could hit a carriage return and then paste. And then we want a semicolon here, definitely. And then another carriage return. And then go up and copy the geographics, copy, paste after this semicolon before that close parentheses, and we want to paste that. And then we need, yeah, right between the very last closed square bracket. So right before the last closed square bracket, we need this function thing, this ampersand. You'll notice this URL turned green here, which means that this is an instant function now. Yeah, that's it. And then hold down Shift and hit Enter, and I think this should be basically good to go. So let me click on this. I'll go back here for those of, no, that didn't work. Oh, I have the ampersand in the wrong place. Okay, so we need this to be right after the parentheses. Okay. Yes. It should be within form page. So it goes right after all the stuff that's in the parentheses. Close form page, close cloud deploy. So you can see now why I put these extra spaces in here all the time. It is to prevent myself from doing exactly what I just did, basically. So this is a whole lot more clear. So hold down Shift and hit Enter. We'll go to the URL. I'm going to share that. And so now I've got the URL. And then, let's see, let me paste in what I had here. There's this one that I like called Ghost Towns, right? No, Ghost Town singular. Well, let's see if there's a ghost town plural. Maybe there is. No, there's not. Okay, ghost town. So what this is doing now, so we've got this copy to Wolfram Cloud where you can, you can send this to anybody. We're looking at my web browser. So anybody in the world can take this URL, which is on wolframcloud.com. They can type in their own Wikipedia page. Well, this isn't working. Oh, no, it is working. There we go. Okay, great. So now we've got ghost towns, and now this is a map of all the specific towns that are listed on that Wikipedia page. When I first ran, I think of ghost towns as a very kind of American phenomena, I suppose. I don't know why, but that's probably a very American biased thing to say. But there are ghost towns in Europe and a couple in Asia here. Looks like Japan and maybe Hong Kong and maybe Africa, a couple in South America. There's the Japan one. That's very, anyway, I won't get too caught up in that. Let me go back to the code. But so this is the whole point where now that we've got this code and we've got this application, you can share it with anyone. They don't necessarily have to understand these things in Wolfram language, but now it's very portable, and you can share these things. This could be something like make a graphic of some sort of chart or some sort of 3D plot or some sort of cellular automata kind of thing, like anything in Mathematica. Now you can make this very portable application that can just be a cool showcase of what you're creating. Okay, so I should probably wrap there because I'm a few minutes beyond time, but I'm happy to stick around and answer questions, but I'll stop there just in case you want to stop the recording and keep the recording at about an hour.